Arithmetic and geometric sequences. So a sequence is a set of numbers that have a definite order. Each number in a sequence is called a term. So in the sequence 1, 2, 3, 4, 5, term 1, we usually use U1 or T1. They mean the same things. The formulas in your IB formula booklet use U, so I'll be changing all the T's to U's. So UN represents the value of the nth term. So if we're given the general term UN equals 4n minus 2, we're going to find the first three terms and then find the 12th term. So my first term would be U1, which is equal to 4 times 1 minus 2, which gives me 2. U2, I'm doing the same thing except substituting in a 2 instead of a 1. So my value for U2 is going to be 6. U3, substituting in a 3. Which is going to give me 10. And then doing the 12th term, I would just substitute in a 12 for the n. So I would get U12 equals 46. So the first type of sequence that we're going to look at is an arithmetic sequence. And an arithmetic sequence is a sequence where there is a constant difference between consecutive terms. So you can see an example there below. The constant difference can always be found by subtracting two consecutive terms. D equals U2 minus 2U1. So here, example 2, we're just going to find the common difference for two arithmetic sequences. So here, I would do D equals 5 minus 9, which is minus 4. And then I would double check another pair to make sure that I'm getting the same values. 1 minus 5 also equals minus 4. Here is a little bit more conceptual one. We've got our second term minus our first term, which is going to make my difference equal to B. And then checking another pair, I would have A plus 2B minus A plus B. Don't forget about the brackets. You're subtracting both pieces of the term, which is also going to equal B. So this example is actually going to help us understand how the general term of arithmetic sequences is found. UN is equal to U1 plus n minus 1 times D. UN is the nth term, D is the constant difference, n is the term number, and U1 is the first term. This formula is in your formula book. For example, given the arithmetic sequence 15, 11, 7, 3, write a formula to find the nth term, and then we're going to find U13. So in order to find the nth term, we need to know what U1 is. We have that, it's 15. And we need to know what D is. In this case, we can find it by subtracting successive values. And this is going to give us a difference of minus 4. So then what I can do is write those out in my nth term. So UN is equal to 15 plus n minus 1 times minus 4. And then what this is going to allow me to do is find U13. So all I have to do is substitute in 13 where my n is, and then evaluate, which is going to give me minus 33. And then part C is the opposite here. So now I know the left-hand side of my nth term equation, and I'm looking for the n value. So here, this is what I know. So UN is going to be minus 69, and then n is question mark, or my unknown. And so I'm going to put in that value for the nth term on the left-hand side, leave my n as the variable, and then I can rearrange and solve that for n, which is going to give me 22. So the 22nd term has a value of minus 69. Let's do another example, a little bit more of a problem-solving one. What I'm looking for here is U31, given that U7 and U15 their values are as follows. So what I know is that U7 is going to be my first term plus 7 minus 1 times d. And I should go back a minute here. So I want to use this formula here. U31 is going to be equal to U1 plus n minus 1, so 31 minus 1 times d. The problem is that I don't know U1 and I don't know d. So what I need to do is use my information that I'm given to create two equations with two unknowns so I can solve for those values. So here, plugging in what I know, I've got 121 equals U1 plus 6d. That's my first equation. My second equation is going to be U15. So almost the same, just with a different left side value. And I'm actually going to write it under here. So I've got 193 U1 plus 14d. This is my second equation. And then what I'm going to do is subtract them. If you think back to solving linear systems, what that's going to do is give me minus 72 equals minus 8d, which tells me that d is going to be equal to 9. Then I can substitute d back into, let's do it into equation 2. So I've got 193 equals U1 plus 14 times 9, which is going to give me that U1 equals 67. So now what I'm asked to find is that U31. So now I can do that because I know my first term and I know my constant difference for this arithmetic sequence, which is going to allow me to find my 31st term as 337. The second type of sequence that you can have is a geometric sequence. And a geometric sequence is where each successive term is found by multiplying the previous term by the same constant amount. An example is shown below. The common ratio, instead of the constant difference, is the constant value each term is multiplied by to get the next term. R can be found by dividing any two consecutive terms. So really U2 and U1. So example 5 is going to ask us to find the common ratio for each. So just like we did for the arithmetic sequence, we would do 12 divided by 3 is 4. And then I would check another pair, 48 divided by 12, also 4. Moving on to B, 64 divided by 16, 4. And then I'm successive terms. So we would have 16 divided by 64, which is going to give me 1/4. And then I would have 4 divided by 16, also gives me 1/4. My next one here, so let's try minus 2 divided by 1 is going to be minus 2. And then if I check another pair, 4 divided by 2 also gives me minus 2. And then my last one, my general one, I've got AR divided by A is going to equal R. And then I'm going to check another pair, AR cubed divided by AR squared is also going to give me R. So this is going to help us get to our term for all geometric sequences, where UN is the nth term, R is the common ratio, N is the term number, and then U1 is the first term. This formula is also in your formula book. Let's look at an example of using the formula. So given the geometric sequence, let's write a formula to find the nth term. So we've got UN equals, we need our first term, which is 4, right here. We also need our ratio, which is going to be successive terms divided by each other, which is 2. So 2 to the n minus 1. So now the first thing that we're going to do is solve for U11, which I can do by substituting in 11 for n, evaluating on my calculator, which is going to give me 4,096. The next thing that I'm going to do is find the term that has a value of 32,768. So instead of solving for U, in this case, the term, I am just looking for my n value, so I'm going to substitute in on the left side. Okay. Again, here, I'm going to take the log of both sides. That's going to allow me to solve for n minus 1. So first thing that I would do is divide by 4. And then I'm going to take the log of both sides. What that allows me to do is bring the n minus 1 down in front. So I've got log 8192 is equal to n minus 1 times log of 2, just like we solved those probability equations way back in Unit 4. Then by dividing both sides by log 2 and adding 1, I'm going to find that my term value is 14. Another example here is finding the number of terms in the following geometric sequence. So here I've got my first term is 1 over 25, and I know that my nth term is going to be 625, and I also know that my r value is going to be 5 here. So what I'm going to do is the same thing that I did for the arithmetic series, okay, is use my equation here. So I know that this is true. Un is going to be 1 over 25, 5 to the n minus 1. Okay. And then I've got here, I know what my un term is, and I'm just looking for my n value. So another example of where you're going to have to take the log of both sides. So I would have 15,625 is going to be 5 times n minus 1. I'm going to take the log of both sides, which allows me to bring down the exponent. Dividing both sides by log 5 and adding 1 is going to give me n equals 7. So that means that there are 7 terms in my sequence. The last one that we're going to take a look at is an example where we're creating 2 equations and 2 unknowns. Okay? We know that the fourth term, so u4 is minus 135, and I know that the seventh term is 3,645. I need to find the first term, the common ratio, and the general term. So un here. So I'm going to use my equations to set up what I know. So I know that u4 is going to be u1 times r to the 3, that n minus 1. And I can also write in what that value is equal to. So u1 r cubed. Okay, this is going to be my first equation. Now my second equation here is going to be u7 equals u1 times r to the 6, n minus 1, and I could put in my value here. Okay. A couple ways, different ways to approach this here. You can rearrange one of the equations. So let's do that here. We've got minus 135 equals u1 divided by r squared. This is okay because our ratio is not going to be 0. Otherwise, we wouldn't have a geometric sequence. Okay. So now we've got a third equation here. And what we can do is we can sub that third equation into my second. So I've got 3,645 is minus 135 over r cubed times r to the 6. That's going to allow me to have an expression only in terms of r. And then it's going to allow me to solve to get that r is equal. So r cubed is 27. And then r is going to be minus 3, making sure that you take the cube root. Then we can substitute our r value back into our third equation here to solve for u1. So I've got minus 3 cubed equals u1. Okay. So this means that u1 is going to equal 5 after I evaluate that. Okay, so I found my first term, I found my common ratio, and now I can state the general term for u1 or un as 5 times minus 3 to the n minus 1.